49th question. A chest radiograph of 36 cm by 48 cm is digitized. If we want to preserve details in the image to a spatial resolution of 6 cycles per mm, the approximate image data size in megabytes for an 8-bit quantization is dash, rounded off to 2 decimal places. Okay, so the key detail in this question is we need to understand what is cycles per mm. We need to understand this unit for the resolution. Okay, so let's take a a single point source. Okay, so if this is a single point source, the way its projection will appear in the image will be a slight spread of the point source. Okay, a single peak will be slightly spread on either side. Okay, so similarly, if there are 2 point sources, okay, one here and one here, we'll have 2 peaks like this. Okay, so essentially, okay, this is a single point source is known as a line. Okay, 2 lines are known as what is known as a line pair. Okay, distance between peak of 2 lines, 2 consecutive lines, okay, is known as a cycle. It involves a peak, which is a bright spot, a dark spot, and a bright spot. Okay, so from here to here is known as what is a cycle. So this resolution could be instead given in say number of lines per mm or number of line pairs per mm. Okay, so 6 cycles per mm as 6 line pairs per mm and or 12 lines per mm. Okay, so given this, if we somehow relate it to the number of pixels that are needed for this resolution, we can go ahead and find the data size, okay, based on this size of the radiograph. How do you find the number of pixels? Okay, so I'm going to make this very informal. For this peak, we need 1 pixel, right? And for this dark spot, we need another pixel. And again, for this pixel, for this peak, we need another pixel. If you notice, this essentially means for 1 cycle, we need 2 pixels, right? Because this pixel is being shared by this dark spot as well. So 1 cycle needs 2 pixels. So this is what is known as the Nyquist frequency. If the pixels are bigger than this, we cannot distinguish these point sources, and this essentially is 0.5 cycles per pixel. Okay, so from this, the way we can find the number of pixels is essentially 6 by 0.5, which is 12 pixels per mm. Based on the Nyquist frequency, essentially if we need 6 cycles per mm, we need 12 pixels per mm. Okay, with that then the answer is pretty straightforward. Okay, so because this is in mm, I'm going to convert everything in mm. So 36 centimeters 360. Along the length we need 12 pixels per mm. So along 360 mm we need 360 into 12. That times again 480. That is the height. Okay, that times 12. So we need this many number of pixels. Okay, and how many bytes corresponds to these pixels? Okay, it's a 8-bit quantization, so it's times 8 bits. Okay, but ultimately we want things in bytes, so 8 by 8. Okay, number of bytes, and we want the answer in megabytes. So divide this by 1024, we get kilobytes. Divided by 1024, again we get megabytes. Okay, so this factor over here turns out to be 23.73 megabytes. A very simple question. All we need to know is how to convert this resolution into the number of pixels per mm. Okay, again instead of 6 cycles per mm, instead they could give 6 lines per mm or say 12 lines per mm or 6 line pairs per mm. I'll see you with another I'll see you with another video. Good luck.